today we are going to talk about ionization energy. So this is one of the terms which is most commonly used in inorganic chemistry, and is one of the terms which is making up the foundation. So ionization meaning what? Ions, and this we are going to be forming ions. How do we form ions? From gaseous atoms. Now let's take an example. We are having magnesium, atomic number 12. So I'm going to draw for you the structure. This is the nucleus. This is the first energy level, having what? 2 electrons. Second energy level, having 8 electrons. And then the third energy level is going to be having 2 electrons. Let me keep it separate for now. Now see, how are we going to form ions? We are going to form ions by knocking out these electrons. We are going to remove the electrons in the outermost energy level. The outer ones are the ones which are going to be less attracted towards the nucleus. Okay, so now in this one we are going to talk about some terms like nuclear charge. Basically this is the attraction of outer electrons towards the nucleus. Then we are going to talk about screening effect. Now what is this screening effect? It is basically just the repulsion. If we are seeing these electrons, negative and negative repel, positive and positive also repel, right? But in this case we are having electrons repelling each other within the atom. So these second energy electrons are going to repel the outer ones. So screening effect, just basically repulsion of electrons. Now see, this is something like a negative way, and this is positive. So if positive is greater than negative, that means you're going to be having what? Attraction of the electrons. In this case, do you think it will be more energy required or less energy required? It will actually be more energy required to remove these electrons. So therefore, if nuclear charge is greater than screening effect, therefore the effective nuclear charge will be greater, right? Basically this is showing you now the net nuclear charge. If it is high, there will be more attraction. Okay, if there is more attraction, therefore more energy will be required. Similarly, if the nuclear charge, let me get this space here, if the nuclear charge is less, or it's less than screening effect, therefore the effective nuclear charge will be low. Effective nuclear charge will be low. That means you will require less energy. Now what is the definition of ionization energy? Let's write it. So ionization energy is the minimum amount of energy required to remove one electron stroke 1 mole of electrons from one gaseous atom or 1 mole of gaseous atoms to form 1 mole of positively charged gaseous ions or 1 positively charged ion. Now see, in this definition we are having 1 electron, so that means you are going to continue with 1 gaseous atom and 1 positively charged ion. Similarly, if we are going to use 1 mole of electrons, that means 1 mole of gaseous atoms and 1 mole of positively charged gaseous ions. Now let's put it into into practice. On the periodic table, okay, we're having periods, then we're having groups. Periods span, right? We're having period 1, 2, 3. Okay, they are spun horizontally, like period 1, 2, 3. Now we are having groups 1, 2, 3, 4, 5, 6, 7, 8. These ones run vertically downwards. Okay, now see, let me get a fresh page here. Okay, so here is my fresh page. Now we're going to talk about the trends of ionization energy across a period, right? As I just told you, let's consider period 3. We are having sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Okay, now what is atomic number here? 11, 12, 13, 14, 15, 16, 17, 18. Now if you are going to look, let's write the electronic configuration of sodium: 2 to 8 to 1, 2 to 8 to 2, 2 to 8 to 3, 2 to 8 to 4, 2 to 8 to 5, 2 to 6, 8, 7, 2 to 8 to 8. We can see here that we are adding the electrons to the same energy level. However, we are increasing the number of, we are increasing the atomic numbers. Now, if we increase atomic number, we are also going to be increasing the nuclear charge. So from sodium to argon, we are increasing what? We are increasing nuclear charge. Why? Because we are adding protons due to addition of protons. Now look at the skinning effect. Since we are adding electrons to the same energy level, these electrons are still that same distance apart from the nucleus. That means the skinning effect remains almost constant. It's not really constant, but it remains almost constant. There might be some minor repulsion which we are not considering is negligible. It remains almost constant. Therefore, effective nuclear charge will increase, and hence outermost electrons are more attracted towards the nucleus. What will this do? This will increase the ionization energy. So you see, we have now derived, it's actually a fact that ionization energy increases along a period. Take any period, whether period 1, period 2, period 3, period 4, any, the ionization energy will generally increase. Now, since we have made up this basic, now how about along a group, down the group? Okay, down the group, what are we going to be doing? We are going to be adding protons, right? It is true, because down the group atomic number is going to increase. Number 1, then number 3, number 11, and so on and so forth. So addition of protons. So this means we are increasing what? The nuclear charge. But now, as we go down the group, we are also going to be adding addition of energy levels. Now this one will make the electrons far away from the nucleus. So if electrons are going to be far away from the nucleus, we are increasing the screening effect. And therefore, if we are going to now do the accounts of this, we are going to have overall effective nuclear charge decreases. Hence, we are going to require less energy to remove electrons. Hence, the ionization energy decreases down the group, because the atom is becoming bigger and bigger down the group. Okay, so this was the basic thing. Thank you.